I hope you can all see my screen. Work zone monitoring. So yeah, we've been kind of testing work zone monitoring in Kentucky for a few years. We have a real-time data system that's been in place for since about 2015. But then over the last few years, we've kind of tested this idea of virtual monitoring. And then this year, our division of construction really decided to jump in and kind of take hold of that and run with it. So I'll go through some of our experience here and some of our tools. Let's see. So this is some of the data that we bring in to our real-time system, and the stuff in red there, the items in red are the ones that I'm going to talk about for work zone monitoring. A few of those say pending, and this is really a work in progress. It's kind of a design build, if you will. So we're really trying to work on this idea of work zone monitoring. So some of these, even though we have the data available, we don't yet have it integrated into some of the tools that I'll show you soon in these dashboards and things, but we do have the data streaming into our system, and we've kind of analyzed some of the data for usage later. But so we're going to combine like probe data from here, waste traffic viewer, incidents, etc. This is a general workflow of how our data comes into the system. All of our data, regardless of source, is pulled into Google Cloud, processed against our linear referencing system to give us, district, county route, mile point. We add 47 fields of data to each and every record we receive to make it very easy to combine all that data together and force relationships between different data feeds, whether that's Doppler radar or speed data, air temp, pavement temp, all those things. We kind of mix all that together. And then what is a work zone, right? So work zone, when we're talking about work zone or work area, for the most part, like our division of construction or traffic management center in the past, when we say work zone, what they're really talking about is that work area. That's the area of the pavement actually being affected or worked on. That does not include, signage or maybe tapering of barrels, that kind of stuff. So we kind of differentiate between these two. And so we've got a work area, but then we also have work zone. We extended the record. So most of our records are the work area. The area of pavement being worked on, and then we extend that area a half mile. That was a decision division of construction made. They extend the area 1/2 of a mile in both directions so that we can do queue monitoring and things as well. So this is maybe a little bit hard to read, but this is my attempt at creating a roadway and different mile points. So you've got kind of a linear representation there, but then you also have this time depth of data here, speed data and things per mile point. And we actually divide it to the 1/10 of a mile point. And I'll show you that shortly. And then we represent this through maps and different graphs, right? So one of the workflows we do with our data is we do pull some project data from Site Manager, Division of Construction Site Manager. That's where they pay for all the projects. That's their payment software. So we thought, well, if they're paying for it, they ought to know what's available, right? They should have really good data on what projects are active along the roadway. And sometimes there's a mismatch between our traffic management center, which has really great operational data, and then construction, which is paying for these work zones to be worked on. So what we decided to do was we pull data from the blue line is kind of the origin line, and that pulls from the division of construction, pull that into Google Cloud. We drop that in our data lake as a raw form, and then we also process this through streaming, or actually drop this into a CSV or JSON. And then our traffic management center picks this up in their software. They enhance this with operational data like right lane close, left lane close, et cetera. And then they move, that gets pulled back into Google Cloud, processed against our linear referencing system, and then goes out to dashboards and other visualizations and analytic tools that we may have. So what is work zone monitoring? This is where I'll jump to some of my slides. First of all, if you're a Waze partner, my suggestion is to go ahead and get started with the Waze traffic viewer. This is a great tool for just jumping in and let's say you don't have time to develop a large big data system and a lot of tools and things. You can immediately use the Waze traffic viewer tool to get in and define a work zone and then start monitoring that work zone through this dashboard. So it's kind of a quick and dirty, right? It also provides a data feed that you can pull in and process as well. So work zone monitoring for Kentucky is, I'm going to start here. I went ahead and preset some of this stuff for you, but so the first thing that our division of construction staff sees is this work zone monitoring. This is just a business intelligence tool available on Google Cloud. It's called Data Studio. It's kind of like a Power BI or Tableau. And so we're going to work zone overview. And you're going to pick a work zone from here, which I've already selected one. I've already selected this project in District 7, Clark County. And then we're able to mouse over each of these points, each 10th mile point, and get an average speed. And currently this is set to the current day. So this is everything since midnight, an average speed per 10th of a mile point today so far. And then we've got just some general metrics at the bottom. This is a little to see like average min speed, average max speed. So what we're doing there, we get data in every 2 minutes, but we have 5-minute buckets of data of aggregations, and we also aggregate to the 10th of a mile. So there may be, in some cases, there may be multiple records, maybe 5 or 6 records that actually go into that due to the way that here divides their linear referencing system, the way we divide that system as well, and then also the number of records. We have at least 2 records for each of these points. So what we do is we kind of create little 5-minute 10th mile buckets. And so we're doing the average of all those min speeds, right? And the average speed overall, and then the average of the max speeds. And that kind of gives us a good measurement of how that work zone's operating. The next page is crashes. So if I wanted to go study a crash, I could look at District 6. And if I filter to District 6, it's going to pull up the one crash that's available. And then I have drill down capabilities to get more specific. Gives me a work zone location, right? So that's I-75, mile points 169.4 to 178. That's the actual work zone itself. And then we've tried to do some other things with drill downs that didn't work, but that's about as far down as we want to go. If there were waste crashes in this area, we would also see those here. There's not at the moment. Let's see, this little bar always gets in my way with, and then we've also got month mobility summaries, right? So we can pick a work zone here, like let's say District 12. We're going to click on District 12. This is out in our Eastern Kentucky area. We see min speeds are 13.5 and average speeds are 61. We don't know where that is. So we actually have one work zone out here. We can drill down. We can see the work zone itself. And we know that District 12, Lawrence County, US 23, this work zone between mile points 23.6 and 28.5. This is how this is performing. And then we can mouse over each of these 10th mile points, and we can start to understand exactly how that work zone is performing at each 10th mile. And then I think we have one more drill down on this as well, but it's probably, oh yeah, I remember this. Then we also have a per 10th mile. Right now we have this sorted by speed. So the 13, this mile point, the 28.4 mile point is the slowest, kind of the slowest moving mile point that we had in that work zone today. And this is set for today. So again, that's just a way to check mobility, kind of deep dive into the work zone itself. I'm going to switch tabs again, go to monitoring. This monitoring is set up to give you the average speeds versus free flow per day. And then this is based on the location. So I picked Franklin County and I-64 non-cardinal direction. And I'm now able to see that, like on July 14th, the average speed was 63.87 miles an hour, but the free flow was 69, right? So the expected, like the annual average is 69 miles an hour, free flow is 63. And then here I can see exactly what mile points were not performing very well. And so I can mouse over those and I can understand that. And of course, those have drill downs as well. And we can get into more specific time periods. And we also take every, this is currently set to a week, but we can set it higher than that. This is giving me the average speeds per day and then per hour. So at 1 p.m. is my lowest aggregated speed, all the 1 p.m.s that I've got between 1 and 2 p.m. And then the fastest speed through this work zone is 8 p.m., which you can see they're actually speeding through there at 71.04 miles an hour. So we've got some pretty high speeds through that work zone. And then of course, same thing, I can mouse over each individual point and I can start to understand that. And then if I think I can filter here too, I can filter that specific point. This is what happens when you do a live demo. I can't remember if we had this working or not, but what the heck. Yes, so I can click on that. I can get average speeds on Wednesdays, and then I also understand my average speeds over here. So we have another page we're trying out, which is the next kind of page 2. That one had the bar graphs. This one, I think people actually like this one better, so we're probably going to keep it. This is just line graphs. Same thing, I-64, non-cardinal direction, Franklin County, and this is just today. And then I can start to understand each, every couple of minutes there. I've got speed data, and I can actually understand where something happened. So mile point 48, and then I've got these mile points here. But then also I have when. So this gives me a great timeline of when there were issues in that work zone. So it looks like there was an issue this morning, probably 8:02 a.m. right around there, 8:04. So. And then again, looks like around maybe 10 o'clock or so, had another issue at 10. And so this just helps our people understand how those work zones performed. And then I've got some other dashboards that we use. This is kind of the inspiration for this. We do a lot of aggregations with speed data, so you can go back and check 7-day averages, and you can just pick a route, and then you can pick either like a area here, like if you want to do I-75, if you want to filter this, and then you can do cardinal versus non-cardinal direction. You can also narrow down by mile points, etc. So we've got kind of this overall page, and then we've got interstates and things. And then I'll end detected incidents. This is something we've been doing for a while. We finally developed a little dashboard for that. We compare here data with Waze data, where Waze data has like a report of a crash, and then we also have here data with 70% or less of free flow. We're now tracking that entire incident over its duration, and so you can see over the last couple of years we've detected 6,700 or 6,600 incidents, and the average duration of all those are 81 minutes, and the average queue length of each of those detected incidents are 2.34 miles. So that's good information as well, especially when you narrow those down to the work zones. And then I have another sheet that I'll share based on our project. I've got all of our storage numbers and different URLs and things. If you're interested in our project and using cloud computing and trying to understand our data, I can make those available as well. I actually have those in, I made slides just in case. And we have delivery emails for anytime there's a crash reported inside of a work zone, we make construction staff available or make that known to them immediately through delivery emails you can subscribe to. We also do per county summaries every 6 hours. If there are work zones with speeds of less than 25 miles an hour, we make those available to the people subscribing to that county. And then we also do one interstate alert where it lets you know when work zones are not performing well. It's 25 miles an hour or less for a matter of 10 minutes. And so we're making those, we're kind of tweaking those a little bit, but we're trying to make those public. That way, trucking companies and other commercial vehicles can subscribe to those. Right now, we're still testing those. They're a little too sensitive right now. We're picking things up a little too quickly. And then, like I said, all of our work zones include a half-mile queue, and which again goes into the whole detection thing and being able to detect traffic backup and queuing. And then those URLs are here, and I'll go ahead and post these in the chat on the webinar. But this is, you can give it a try. This is our Waze traffic. This is Waze traffic your tool if you're a Waze partner. This is our work zone monitoring that I ran through the dashboard, 7-day traffic performance, detected incidents, and our project documentation. And all this is available to, again, to our construction staff and also consultants, contractors, etc. The goal here is to produce safer work zones, increase safety and mobility. So like our traffic management planners, the TMP training, which our folks are required to renew, I think it's every 4 to 6 years. We're getting ready to include all of this in their curriculum. Division of Construction obviously looks at this both at central office level and then at district level. They're starting to roll this out to the districts now, getting them involved. So we're really, this is the year we're really kind of, I say we're in development. We've got a lot of stuff in production, but we're still going to continue tweaking this and making it into like a full-blown solution for our agency and roll it out as an enterprise, kind of an enterprise adopted solution. So that's all I have. I will go ahead and post these in chat here as soon as I copy these over, but I will go ahead and turn it over to back to somebody.